Welcome to this explainer. Today, we're covering Lesson ID STEM-AI-STEM-AI Unit-05-Lesson Pack-04-Reasoning Review and Transfer Video Overview, which has the exact title, Reasoning, Review and Transfer Video Overview. We're going to connect some seriously critical dots in artificial intelligence today, so let's jump right in.
Section 1. The Logic Misconception. So, there's this massive misunderstanding out there. We often fall into the trap of thinking that if an AI system's reasoning seems perfectly logical and, mathematical, then we don't need to run any further ethical or societal checks on it. It's super easy to assume that because computers use objective numbers, their final decisions must automatically be fair. Like, we think to ourselves, hey, the math checks out, so it has to be right, right? Well, actually, scratch that. Today we're going to completely shatter that assumption.
Section 2. The AI Action Cycle.
To see exactly why that assumption is so flawed, we need to look at how the OECD actually defines artificial intelligence. It breaks down into this three-step perceive, reason, act cycle. First, you have sensors collecting raw data from the environment, that's perceiving. Then, the operational logic interprets that data, that's the reasoning part. And finally, actuators actually change the environment based on that output. Look at where reasoning sits right there in the middle. It's literally just the machine processing what it perceived. It doesn't inherently know right from wrong at all. Section 3. The NIST Trust Check.
Because reasoning is just that middle step, we absolutely need a dedicated way to check the overall safety of the entire system. Enter the National Institute of Standards and Technology, or NIST. They created a voluntary framework specifically designed to manage risks to individuals, organizations, and society as a whole. They basically recognize that you can't just release an AI into the wild simply because its internal logic functions properly. You have to have a structured way to build trustworthiness into the very fabric of these systems.
And that brings us to their core functions: govern, map, measure, and manage. The crucial takeaway here is that these functions exist specifically to check trustworthiness, going way beyond just asking, does the reasoning seem logical? This framework literally forces creators to identify the context, analyze the risks, and actually take action to minimize potential societal harms. A machine might logically spot a pattern, sure, but it's totally up to this human-driven framework to step in and say, wait a second, is this actually safe and fair for everyone?
Section 4. Worked Example. Classroom AI.
Let's bring this into the real world with a grade 7 classroom example. Imagine a hypothetical AI system deployed right in your school, and its only job is to organize the lunch line as fast as humanly possible to maximize everyone's eating time. The AI sensors collect data on student heights and walking speeds. Then, its operational logic kicks in and calculates a trend. Taller students generally have longer strides, so they walk faster. So boom, it decides to always put the tallest kids at the front of the line and the shortest at the back.
Now, check out this sharp contrast. The AI's reasoning is completely logical if you only care about speed, but it completely and utterly fails the NIST societal impact check because it creates a massively unfair bias. The math is sound. Taller kids do cover ground faster, but the second we use the NIST framework to map and measure the risk to individuals, we spot a huge societal failure. Younger students, or just kids who happen to be naturally shorter, get banished to the back of the line every single day. The logic works flawlessly, but the ethics? Total fail.
Section 5. Transfer Task. Your turn.
All right, now it's your turn. Let's apply this combined reasoning plus ethics check to a totally new scenario taken straight from the OECD guidelines. Imagine an AI credit scoring system. This system uses historical borrower data and specific rules to make a recommendation on a credit score, which ultimately decides whether to approve or deny a bank loan.
So here is the big question. Take a second to really think about this. If the loan approval math is perfectly logical, does it automatically pass the NIST trustworthiness check? Just because the AI deduced a mathematical trend from historical patterns, is it automatically safe for society? If the internal math is absolutely flawless based on the data it was given, can we just go ahead and skip the ethics check?
The answer is a resounding no. Mathematical logic absolutely does not guarantee societal fairness, especially if the historical data itself contains human biases. Think about it. If the historical data used in the perception stage was already biased against certain neighborhoods, the AI fails the NIST measure and manage risk functions, even with perfect math. Machine learning AI teaches itself over time using the data we feed it. So if humans in the past unfairly denied loans to specific groups, the AI just perceives that as a logical rule to follow going forward. The reasoning is mathematically accurate, sure, but you absolutely need the NIST framework to catch the severe ethical harm it would cause.
Section 6, Review and Final Takeaway.
Let's wrap up this explainer by connecting these concepts back to the core framework of your course. To truly evaluate an AI, we have to move past that initial logic misconception. We have to actively evaluate the operational logic, apply the NIST risk management framework, and confirm its societal trustworthiness. You simply cannot have step 1 without step 2. Every time you encounter a new AI tool, you have to ask both, how is it reasoning and what is its impact?
And this really brilliantly illustrates the connection between the AI for K-12 guidelines. You literally cannot have Big Idea 2, reasoning, without checking it against Big Idea 5, social impact. In your grade 7 curriculum, these aren't just isolated chapters. The operational logic of how a machine represents the world and reasons through a problem directly dictates its social impact. They are two sides of the exact same coin. I'll leave you with this final thought. Knowing that logic doesn't equal ethics, what societal impact check will you run on the next AI system you encounter? The next time an AI gives you a perfectly logical answer, are you going to be the one to stop and ask if it's actually trustworthy? Mathematics is incredibly powerful, but human judgment, frameworks like NIST, and our shared commitment to fairness are what actually make AI safe for society. Keep questioning, keep analyzing, and I'll catch you in the next explainer.